Hello everybody, and welcome to today's webinar presentation, High Performance WebSockets on Android, brought to you by Mason. I would like to introduce you to our presenter today, Stephanie Kondick. As an industry veteran of 20 plus years, Stephanie has a passion for technology in all forms. Her experience spans tech, healthcare, media, mobile, and VR at various companies including Samsung and Oculus. Her Android background is deep. She founded the Cyanogen Mod open source project and later the startup Cyanogen Inc., where she served as Chief Technology Officer. From embedded systems to digital audio, Stephanie knows her tech and she knows how to build great and diverse engineering teams. Stephanie joined Mason 2 years ago as a principal software engineer, and today she leads software efforts as Director of Software Engineering. At this time, I'd like to pass it off to Stephanie for the presentation.
Hello, thanks for the introduction. I'm Stephanie Kondick, Director of Software Engineering at Mason. Today we're going to talk about building high-performance WebSocket applications on Android using the Netty framework and Mason. So today we're going to be building a fairly basic multi-user chat application using WebSockets. We're going to deploy this application to a dedicated device bank using Mason. What we're going to be building is a high-performance Netty client that talks to a Golang service. The Netty client is going to be using the native ePull connector, which is somewhat tricky to get working on Android, and I'm going to take you through everything that it takes to get that running. The native clients will give you improved performance versus the NIO clients, largely due to reduced garbage collection on the platform, since we are going to be working in Java and Kotlin. We'll be deploying our application to multiple dedicated devices using Mason. Mason is a framework for managing a fleet of dedicated devices and the applications that run on those devices, and we'll be talking more about that in a bit. So here's what we're going to be building today. We're going to be building a chat service that talks to a number of different devices, and these devices are going to be communicating with the service via WebSocket, and we want the performance of this application to really shine. We built a similar system to this at Mason for our remote access system called X-Ray. And we really wanted it to be as fast as possible because we were streaming video with it and sending packets directly over WebSocket. So we wanted it to be as fast as possible, and we found that we could get those kinds of performance improvements by using Netty's native connectors. We're also going to talk a little bit about some future directions, which we probably won't have time to get into as part of this webinar. As far as offline and background usage. As far as offline and background usage of the application. Okay, let's talk about our application. Our application is called Mason Chat. It's a really simple multi-user chat client. You've probably seen these kinds of applications before. It's kind of a really great way to demo WebSockets. It's something that it does really well. We're going to be using Kotlin, mostly for simplicity, and it's just nicer to work in. And we're going to use Netty's ePull connector. Now, Netty is built on top of Java NIO, which is fairly fast, but often there's lots of garbage collection that happens, which stalls your connections. The other issue is that there's lots of wake-ups that happen using NIO, which really don't happen when you're using ePull. One of the problems that we ran into at Mason when we were building this out was that we needed to support multiple architectures, including x86, ARM32, and ARM64. Netty doesn't provide an easy way to do that. Using Gradle or Maven, you can use a classifier to pull in the native library that you want to use for your platform. However, On Android, this doesn't really work because we need to bundle multiple shared libraries with the application, and we don't really have a way to do that using just Gradle and pre-built libraries. So we're going to have to build the native piece ourselves, and I'm going to take you through how to do this. We have a couple of behaviors we want out of the application, and we've implemented the foreground behavior, but we're not going to be able to get to the background behavior today. We'll do that in a future webinar. The foreground behavior is that we want the application to connect to the service using WebSockets. We want to handle the incoming and outgoing messages with Netty. And we want those messages to be visible to all users that are connected to the chat server. So you can think of a typical like group chat messaging application where you're typing stuff into the chat and other people are able to see it, and whatever they're sending, you're able to see it right away. It's broadcasted to all the users. Now, some future directions for this is when the application is in the background, we probably don't necessarily want to stay connected. We probably want to receive push messages from the server, which would tell us that new messages are waiting. And we would display an Android notification to the user in that case. This is pretty straightforward to do, and it is going to be a little bit beyond the scope of our work today. But these are future directions, and it's likely that that I will publish the code for doing these things in the next few days. Here's a quick walkthrough of what the code's going to look like before we dive into IntelliJ and have a look. So our main activity is at the center of things, and it's just a typical Android activity. There's a few things that are hanging off of it. Notably is the chat service. The chat service is responsible for spinning up the Netty event loop and managing its lifecycle. Now, if you've worked with Netty before, you know that it has a number of event loop implementations. One is an NIO event loop, one is ePoll, one is KQ. It depends on the architecture that you're using. Now, we are going to be using ePoll. Netty is an asynchronous framework, and it's meant to run in a single thread. What we need to do on Android, though, is we need to run it inside of an Android service, but we also need the Netty event loop to run inside of a thread. So inside the service, we're going to spin up the event loop on a thread and run it on an executor in the background, and we're going to manage its lifecycle. The chat handler is an implementation of a Netty handler, which handles all the WebSocket communication and the connectivity to the remote system. And you see Netty is talking to the Mason chat service. Main activity works with a message list adapter to display the incoming and outgoing messages in a nice kind of text messaging application sort of way. To facilitate communication between the different components, we're going to use Green Robot's event bus. Now, you can do this without event bus, and that's how I originally implemented it. But what I found was I had to implement a handler thread, and I had to implement multiple handlers in different places to be able to pass data in real time from the chat service to the chat handler, and to pass messages from the main activity to the chat handler. And it seemed to be a little bit too complex for my liking, so I ripped it out and I ended up using Event Bus, and it's really nice and clean, and it's really just a pleasure to work with. So with that, let's go ahead and dive into IntelliJ here and take a look at some of this code. So this is a pretty straightforward Android application that you're going to get, if you build a standard Android app skeleton. I decided to use Kotlin for implementing the classes in the application, and we're going to use Gradle to build it. So what we're looking at here is we're looking at the build.gradle for our application. And there's a couple of notable things in here that we need to have a look at. Most importantly, we are going to bring in our Netty dependencies. And in this case, we need to bring in, we need to specify Netty codec HTTP which will bring in the core Netty libraries, which are dependencies. And we need to specify Netty transport native epoll, which will bring in the Netty epoll library. Now this will bring in the Java side of it, but it won't bring in the native JNI side, which we'll be building later, and I'll show you how we do that next. And we'll also be bringing in Green Robot Event Bus because it's just great and it makes talking between Android components just a pleasure. And scrolling up here, there's a couple of things that we need to do to get Netty working properly with Gradle. And one is the packaging options. The Netty jars have some duplicated files, and Gradle really doesn't like that. So we're just going to include them because we don't need them anyway. Next, we're going to tell it that we need to build the Netty JNI library. And to do that, we have this block right here. And this tells external native build, and we're going to build it with the Android NDK. And we need to specify the path to our android.mk file, which tells us how to build the native component. So let's have a quick look at the pieces of this application. Let's have a look at main activity. So in main activity, we're largely just spinning up the UI. We have a recycler view with a message list adapter, and this isn't anything really special. And it's back, the list adapter is backed by an array list. And we have a button, and we have a text entry field, and we have a big open area to view the messages that have come in or gone out. When the application is starting up, there's a couple of things that we're going to do. Notably, the first thing that we're going to do is we are going to start the chat service in the foreground. And a chat service is an Android service implementation that is going to handle it's going to facilitate all of our network connectivity. We're also going to spin up the Green Robot Event Bus. And we're going to set up a handler in our main activity using Green Robot that will look for incoming message events on the bus, and it will populate our message list by adding the new messages to the message adapter. And we also have a helper function in here that will send a chat whenever the send button is pressed. And it's going to do that by sending a message on the event bus. And in this case, we're going to do a send message event, and we're going to send it using our nickname and the chat string that we got. So let's have a look at this chat service. Now, there's a number of things to unpack here. There's our event loop group, which again, for Linux, we're going to use the epoll event loop group. Now, if you check the Netty documentation, there's several different implementations like KQ, there's epoll, there's NIO, and there's some experimental ones. Notably, there is an IO ring implementation that I'm very excited about, which is going to be available later. I think it's still in there, Incubator. It only works on Linux 5 and up, which we're not using on these Android devices. So we decided to go with epoll. And an executor just to make it simple to spin up threads. The first thing that we do when this service starts is we're going to spin up our chat thread. And we're going to submit it to our executor, and we're going to run it. And the reason why we need to do this is because the service is just going to kind of sit there, but at the same time, we need to do some communication with it. So we really want that Netty component running in its own thread. So in this chat thread, we have a few things going on. We're going to start with the init. So in the init, we're going to initialize some basic stuff. Where are we going to connect to? And we're going to create our handler. And our handler is an implementation of Netty's interfaces which allow us to react to events, and we'll talk about that more in a moment. And we're also going to subscribe to the event bus for this class. Now when the thread runs, we're going to do a few things. We're going to start our Netty handler. And the Netty handler returns a future, specifically a channel future, which is different from a future in Java, but serves the same capacity. When we get that future back, we're going to ask for it to sync, and we're going to ask for the channel, and then we're going to close it. Now, all of these are stacked. These are all stacked requests. However, they're not going to happen until we're not going to shut down the channel until things happen, like there's an interrupt. And we have some other code just to stop things when they're done. Now here we have a little bit more event bus code. So what we're going to do here is we're going to subscribe to events that are sent messages that have been placed on to the event bus from main activity. Now these are messages that we need to send to the Netty handler. So we're going to listen for those, and when we get them, we're going to send them right over to the handler. Pretty straightforward stuff. This would just be an outgoing message. And we can't talk directly to the Netty handler from the main activity, so that's how we're using this event bus. So let's move on and have a quick look. Well, and have a quick look at what this event looks like that we're talking about and sending around. So this is just a really simple, plain old object, and all it is, since we're keeping this implementation really as simple as possible, we really just have a sender name, which is like a nickname, and in the case of this application, to keep it simple, we're just using the serial number of the device that's been automatically obtained. And we have a toString function which converts it to a colon-delimited string. We have a couple of subclasses here. One is send message event, which is exactly the same as chat message event. And we have incoming message event, which adds the from method on a companion object, which allows us to really simply just split an incoming string that's colon-delimited and then return the incoming message event. So really simple stuff. And the reason why we want these two separate classes is because we want the Green Robot event bus to easily distinguish between the two events when they come in. And next up is the Netty handler itself. This is the chat handler. So let's have a look here. If you've worked with Netty, you've seen a lot of this before. We're going to talk through the WebSocket case, which Netty is really good at doing. We're going to start here in our start function. In our start function, we're going to do a few things. We're going to initialize SSL first if we're using it. And in this case, we're actually not, but we have a code here just in case we need to. And the next thing we need to do is we need to create an instance of the handshaker. Now, if you know how WebSockets work, then you know that what we do is we make a standard HTTP connection, and then we send a header that requests a WebSocket upgrade. So things like authorization and that sort of thing will happen first, and if everything goes well, then we can ask for the upgrade. Now the handshaker asks for that upgrade to happen. The next thing we do is we create a Netty bootstrap. And the bootstrap initializes the channels on the event loop. In this case, we're going to set up a number of components as part of our chain. So we're going to create this pipeline. The first thing that gets added to it is our SSL handler, if it exists. And that's actually going to be at the end of the chain for now. And the next thing we add is going to be the actual HTTP client codec, which goes after the SSL connectivity. And we need this object aggregator so that any split packets come to us in a single object. And then if we have logging enabled, we're going to add a logging handler just to tell us what's going on. And we need to add the flow control handler, which makes sure that certain things are only sent at certain times. And then lastly, we're going to add an instance of this class itself, which is our chat handler, which actually handles everything in the protocol itself. With the bootstrap in place, we can make a connection. By calling connect on the bootstrap with the host and the port that we're connecting to, we can get an instance of the connection. We can get an instance of the channel by calling sync and then channel. And then we'll return the handshake future, which is an object that will, which is a future that will finish whenever the handshake is complete and the channels are ready to go. Here we have a very straightforward send method, which gets called whenever we want to send a message on the WebSocket. It very simply calls write and flush with a text WebSocket frame with the message that we've given it. Here we have a couple of internal Netty pieces, which just tell us that we're going to spin up the handshaker, where to spin up the handshaker, and that our handshake future is actually a promise, which we can listen for completion later. Now here's the actual part that handles the data coming from the server. Channel read 0. There's a few things happening here, and we have to sort of step through each of the possible things that might be taking place. The first thing that's going to be happening is we need to do the actual negotiation with the service, and we need to do the handshake, and we need to handle any error conditions that happen during the course of that. So we'll get an instance of the channel, and we'll see if it's complete already. If it's not complete, then we need to do the handshake. So we'll call finish handshake, and we'll want to get the full HTTP response back. And if it worked, then we can tell our future that it's successful and we can continue with the application. If not, we'll set a failure on the handshake future, and everything else will just fail. So looking ahead, once the handshake is complete, now this will return once the handshake is complete, and channel read 0 won't get called until there's more data. But there will be more data after this because it's going to be a full HTTP response. Now, we want to check if there is a full HTTP response that is coming through because outside of the handshake, because if it is, then our WebSocket upgrade failed. And we need to probably just throw an exception or handle it in another way. We're just going to throw an exception to keep it simple now because that shouldn't happen and something really went wrong with the negotiation of the connection. In the next part, we have a case here to decode the frames that are coming from the service. And there's a few different kinds of frames that we're going to be using. One is the close frame, and the close frame is if the server says that things are shutting down. And it's really simple, it just shuts everything down. The other kind is the ping frame. And the ping frame is going to handle keep alive with the server. So periodically, once every minute or every few minutes, whatever we set the time to, the service will send us a ping frame, and we need to respond with a pong frame within a certain period of time. If we don't, then it'll drop our connection. So all we need to do is we just need to create an instance of that pong frame, and we need to send it out. And in this case, we're going to wait for the pong frame as well. We're going to make sure that that pong frame finishes, and we're going to make sure that the server got that pong frame. And we're going to do that asynchronously using futures here. So we're going to look for a read, and we are going to close it if for some reason the future was not successfully finished. And the last case here is the text frame. Now in the text frame, we are going to be handling incoming messages from the server. The text frame is exactly what it says it is. It's just a blob of text. So all we're going to do is we're going to create an incoming message event from the frames text, and we're just going to post it right on the event bus. And what'll happen there is that message will be picked up from the event bus on main activity, and it'll be displayed to the user. We have a couple of overrides here just to handle error cases. There's channel inactive and exception caught, and we do some extra work to make sure that our handshake is handled gracefully and we display the right message to the user. Okay, the next thing that we're going to look at is we're going to look at the JNI component. And this was a little tricky to get working on Android. So I'm going to show you how we did it, and hopefully this gives you everything you need to get started. So in this Android.mk file, which is under source main and Android.mk, which is under source main JNI Android.mk, we have a number of things happening here. This is a make file that's used by the NDK to build the C files that are associated with this native connector. And the files come from 3 separate places inside of Netty. Now, Netty actually provides this library, and if you were building like a desktop application, you don't need to do any of this. You can just bring in the Netty libraries using Gradle or Maven or whatever you're using, and they'll likely get found by the runtime. But Android has problems with this, and we need to build for all the architectures that we support so that we can bundle them all into the final APK. So what I've done here is I've enumerated all the files that we need. And these are a number of files. One, starting off, is the Netty JNI utility, which is a standalone repository that Netty maintains that is just a bunch of JNI helpers to do a bunch of boilerplate, very straightforward. The next piece here is the source files, and these are from the Netty transport native Unix connector, which are typically used for connecting to native Unix sockets. And there's no Java implementation for doing these things currently in the version of Java that's being used. So Netty does it all with its own C library. And lastly, we have the C files for the Netty epoll connector. And there's just a couple of them, pretty straightforward. And we have our paths for our includes and some C flags to build it with. Now, next, we have to build this library using a very specific name that Netty's going to look for, and that name looks like libnetty transport native epoll and then an extension. We're going to build these all together as a shared library, and we're going to build it for ARC64 or ARM64. We're going to build it for x86-32, and we're going to build it for x86-64. So what will happen here is that from our Gradle file, which was here, we've specified the path to our Android.mk, and that will go ahead and that will build the application for that, and that will build the native components of the application for us. If we want to take a quick look through here, I'm not going to do this today. You're welcome to do this on your own. These are the Netty connectors. These came straight from the Netty source code. What I'm going to show you here next is how we go from Netty, from a Netty source repository to get these files. Now, the thing about JNI is that we need to make sure that the library, the method signatures in the native library are the same as the method signatures in the Java code. And this often changes between different versions of Netty. So if you change the version of Netty, and currently we are using 4.1.65, you'll need to update your source components. So I put together this really simple script, and all it's going to do is just copy a bunch of files from the Netty source repository. So what you're going to want to do if you want to use this is you're going to want to check out the relevant version of the Netty source code or download the zip file. You can find where to do that from Netty's website, netty.io. And we're just going to enumerate all the files and where they need to live. So this is just going to copy all the files. Really straightforward. We can run it, and it's just going to copy a bunch of files in our directories. Now that we have this going, let's have a look very quickly at the chat service itself. Now, our chat service, we're not going to go too deeply into. The version that we're using of the chat service is pretty simple, and it is one of the Gorilla WebSocket sample applications that we modified slightly and added things like nickname handling and a few other things. It's written in Go. We're going to have a quick look at the code. It's really simple. So let's have a look at that now. Let's just dive into Golang, into Goland here. Really straightforward Go service. In this code, we're using the Gorilla WebSocket library, and you can find that at github.com/gorilla/ several other different things like mux/WebSocket, etc. And this is a really simple handler. We are going to set up a router which handles a couple of paths. The important one is /chat/nick. So the client, the Netty client, will connect to this endpoint, and it will connect with its own nickname. It will connect with its own nickname, and that will be unique. So there's a couple of other supporting pieces of code to this. One is the hub, and one is the client. Now the hub is a collection of all the connected clients, and it's really straightforward. We keep a map of all the registered clients, and we have a number of channels that let us broadcast between the different between the clients and to registered clients, unregistered clients. We're going to set up our hub with our channels and our WebSocket upgrader, which we talked about before, which handles converting the connection from HTTP to WebSocket. When the hub starts, it's just going to do a few things. It's just going to go into a Go routine, which spins and waits for clients to talk on these channels. So that means it's either going to call into register or unregister or broadcast. And for registration, we're adding a client. For unregistration, we're removing a client. For broadcasting, we're taking a message and we're broadcasting it to all the connected clients except for the one that sent it. We're taking the message and broadcasting it to all the clients. In our add client method, we're going to look at the query string, and we're going to parse the nick out of it, the nickname, and we're going to make sure that we have it because we need it. And then if we have it, then things should be good for our simple case, and we're going to go ahead and upgrade that connection. And then we're going to add our client, and we're going to register it with the hub. And we're going to send down a nice little welcome message. And then we're going to go ahead and start our client. Let's have a look at our client. This is also really straightforward. This is just a Gorilla WebSocket code. We set up a few timeout periods and initialize a few things. An instance of the hub, what's the client's nickname? an instance of the WebSocket itself, and the buffer channel, which allows us to queue up messages. We have a couple of things here. We have a couple of Go routines. One is read pump and one is write pump. Read pump is going to read in messages from the WebSocket and route them appropriately. And it's also going to handle pongs. In write pump, we're going to do a couple of other things. In write pump, we're going to broadcast those messages to all the connected clients. So we set up a timer to make sure that we don't spend too much time doing this. And then we go through and we dump out our buffer channel queue and send a message to each connected client. I'm not going to go into the deep details of how this code works right now, but you're welcome to dig in and go through the Gorilla docs and learn more about it. In the start method, all we're doing is we are starting the necessary Go routines for this all to work. Okay, the next part we're going to talk about is we're going to deploy this application. We're going to build it and we're going to deploy it, and we are going to get it up and running on a pair of devices. Now, these devices are provided by Mason, which happens to be the company that I work for. These devices are going to be dedicated to running this application. So this is a simple kind of contrived use case, but you can see how you might want some mobile devices that really just do one thing. And today, they're just going to be doing a lot of chatting. All the devices in our system are going to get updated together, and we can scale this up to any number of devices. Today, we're just going to be using 2. And really quickly about Mason, Mason provides dedicated hardware in multiple form factors. Today we're going to be using our G450 tablets. We provide management software to control a fleet of devices, which includes MDM functionality, OTA deployment, configuration management, and remote access. You can lock devices to a single application, sort of kiosk mode, so that once the device starts up, the user can't actually get out of the application. It becomes all they can do with the device. And using Mason, we can deploy applications, boot animations, splash screens, and configurations to all the devices in your fleet. So the prerequisites for this piece are to have a Mason dev kit, and we have a URL to get that. And I also list out the quick start for connecting your devices, which I've already done. I've already signed them into Mason, and I've already installed the Mason CLI on my system. So next we're going to create a Mason project. A Mason project consists of a number of resources and or assets, plus a YAML file which describes the contents of the project. So the first thing that we need to declare is some OS information. Now, in the OS information, we want to describe the name of our project, in this case, DZone webinar. We want the latest version. And we're also going to talk about the configurations that we need. So the main thing is this direct boot package, which, is this direct boot package. And you'll see below here, in our list of applications, we have Mason Chat, and we list out the package name and the version code for it. Now this direct boot package will tell us, will tell the configuration system what package should be displayed immediately when the device starts. And just to illustrate things, I'm setting disable key guard to true, which makes it so that we don't actually see the lock screen. And this may or may not be behavior that you want, but we're gonna do that. To deploy the application, we need to register the config, register the APKs, and then we need to deploy it. We're going to go through this whole process. So let's go ahead and do that. Okay, so The first thing that we want to do is we actually need to build our application. So let's do that by running Gradle w build. And we're going to do the release build for running with Mason. You'll need to have a non-test key signed application or a non-well-known key signed application. Now, as you can see right here, from the output of Gradle, we've just built a number of versions of the library. We've built the ARM EABI v7a, which is the library for older ARM 32-bit only devices. We've built the ARM64 version, which is for ARM64 modern devices. We've also built a 32-bit x86 version, and we've built a 64-bit x86 version. And those will all get packaged up, and we have our build successful. So the first thing that we want to do is I have our Mason chat configuration here. The first thing we want to do is we want to register our assets. The first thing we want to do is Mason register APK, and then we're going to give it the path of the release build. Whoops, I'm in the wrong directory. Let's try that again. Okay. Boom, done. Okay, Mason now knows about our new application. The next thing we do is Mason register config Mason chat.yaml. Okay, now we're going to step over to the Mason controller. Now this is our web application that lets us configure devices. What we're going to do is we are going to move these two devices, which is my G450A DZone 1 and G450A DZone 2. These are the devices which I will bring up on the screen in just a moment. These are the devices we'll be using today. They're a pair of tablets. When I click move, what's going to happen is the Mason software is going to spin up, and it's going to start a build in the background for the images that are needed to turn these devices into our dedicated chat machines. So let's go ahead and move those into the DZone webinar group. So let's make that happen. Okay, two devices there. And we have our Mason project here, and we can see that we just did a build. I have a couple of previous versions that I set up when I was putting this all together, but the current build is version 3, and we see it was successful. So now that it was successful, we're going to go ahead and run Mason deploy. We're going to run Mason deploy. So Mason deploy -- push config DZone webinar 3 DZone. Okay, so what does this mean? So what we're going to do is we're going to deploy a Mason configuration, which is what we put together with our application and our YAML file. We're going to deploy that, which is called DZone webinar version 3, to the DZone group. We specify the push parameter so that our changes take effect immediately. Now, I'm going to go ahead and switch over to our devices. So let's get those going. Okay, a couple of very straightforward Android devices right here. we're going to go ahead and we are going to deploy our configuration to these devices, and in just a moment so we're going to go ahead and deploy the configuration to our devices, and you'll see that they're going to request to update. We're going to go ahead and do that, and we're going to have a very quick update process where the software is going to reconfigure the device into a kiosk mode, and it's going to set up our new application to run as the main application. So when this comes up, the very first thing that we should see is we should see our chat applications running on both devices, and we should be able to communicate between them. So let's just wait 1 second. We should be ready to go in just a moment. All right, here we go. Okay, and here we are. We see 2 devices. Welcome to Mason Chat on both of them. Let's go ahead and try and send a message. We can send from one, and it shows up on both. And let's try over here. And it works. So what we've done is we have built a multi-user chat application using high-performance Netty components, and we've deployed it to a pair of Mason devices and made them dedicated to this task. So now we have 2 very powerful chat devices. And that's it. Here's a few resources if you would like to continue further. docs.bymason.com is where you can learn all the internal information about how to use Mason. Netty.io, where you can learn about Netty. The source code for this application and the service itself are available on GitHub, github.com/masonamerica/DZone webinar. And here's also a link to the Android NDK for doing native development. Thanks for your time today, and I hope you learned something. Have a great rest of your day. Thank you.
And with that, DZone would like to thank Stephanie for a great presentation. DZone would also like to thank Mason for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.